Поговорим сегодня про IPmap.
So we'll talk about IPmap today, but before we start, I want us to change the subject, and I want to show you what that very often the connection of end users, the quality, expressed in the speed provided by the provider, but never just they never take into account the speeds between the users. So because we're often a peer-to-peer, for example, phone calls through internet, etc. So that's why we decided to do this visualization that would allow to evaluate that. So we call it a sketch because we use the data from different sources that are not 100% authentic and reliable, and so it's kind of a disclaimer. It's not 100% a robust and reliable instrument. We use RIPE Atlas, and for this we use different data sets. For example, Subnica and PRS, country JEDI. So Kaida, S2org, PeeringDB, etc. And so what it looks like, let's see. It looks like this. It's a kind of a segmented kind of circle, and so then the size of each segment is proportionate to the number of users in a certain network. So, for example, this is Netherlands. So then the green little circle shows that it's end user network. If it's blue, it's a transit provider. If it's green lines, then it's connections between end users and networks. Blue lines show transit through transit providers. Orange circles, they are exchanges, and the lines that go through the orange lines are links through the exchanges. So then a broken line shows the incomplete data. Trace route got snapped, or just or we cannot do the geolocation properly. That's what it looks like. So this is what it looks like for the Russian Federation. And so this part not painted of the circle. So these are the operators. So then the percentage of users each has less than 1%. So very small one. So the gray segments, they are no probes there. No probes there. That's it. And thus this system works. That's what it. So the next one is geolocation. Geolocation. Why we went into this when we have other methods of geolocation? Because first, there's increased interest in IP geolocation, not only in the content providers, then on the part of operators, the researchers, they have growing interest to geolocation. And geolocation of infrastructure, that's what they want, focus on infrastructure. And the geolog attribute in the database is not a solution, and so we need to go further. And so then we'd like to have kind of a unified, holistic geolocation format. So the next so geolocation is very complex by itself. So there are many ways how to address it. But no way can be used in a single fashion. So we need just to integrate. We need to set up a platform which would involve different geolocation engines and put them together and give a chance to the users to teach the system, to validate. And so that they could put their own geolocation, set up their own geolocation. What are the approaches? Triangulation, aka trilateration, based on RTT, TTL, So, for example, you can give a good example of Restack Unicapture Atlas is used, Peristack Unicast is used, DNS-based location inference from QIDA is used, different administrative analysis, peering DB, RIPE database is all being used. Commercial offerings, so they concentrate on the end user IP addresses, but not on infrastructure. Secondly, their methodology is not transparent, and IPv6 is badly represented. Would like to integrate that, and attempting to do that, and they use all these engines together, and to give each engine a certain weight, depending on different conditions. And then to show how it works, and to give complete transparency in decision making. That's what it looks like. So we see that geolocation engines, different geolocations, each one so has its own weight. Then we reduce it, and then eventually we get the final result. What would like to have? First, so what we have built, you can find it on IPmap ripe.net. So we have a web application where you can query the geolocation of an IP address and adjust it. Then there is an API there where we can query for multiple IP addresses in bulk. And at the same time, you could enter geolocation for IP addresses which you know beforehand, which you knew beforehand, and then web application for visualization of trace routes. How does it work? On the Atlas site, you select trace route, and then you click it on IPmap, and then you get this this map where we can see different trace routes. Here's trace routes to Wikipedia. Trace route. You click you increase the map and augment it, and you can see these trace routes. There's this light lines show how many hops. They're not geolocated. The geolocated hop is represented with red dots. And then after we have launched this application, the system is trying to use Atlas for geolocation of other hops. So it launches additional measurement of Atlas and uses triangulation. So, but you can see this. The full circle means it's 100% probability that this address is actually is tied to this place. This is 50%. This is tied to this specific physical place or site. So you can enter your own geolocation. You can correct it as well. So, for example, you correct it. For example, Tierney and Italy, and then hop keeps moving to the right place. Is moved to the right place. And API is quite easy, and so the biggest challenge IP address, and then you geolocate it, and then you get all the information that you know about it. Another option is partials. Partials will show what engines were used. So 4 engines were used in this specific case, and each has its own weight. And so then triangulation engine shows it's signed here that if it's not yet full, then in 3 minutes, once the Atlas results of the measurements appear, so then you can reboot Atlas and see what data is there. And this is, so I tried just to put everything in a short period of time. And for this, that's why we need coverage. We have good Atlas coverage to do all that. So even just one minute before. Yeah. Okay, thank you. So then question, raise your hands, please. Question, if you have any questions. Alexander Azimov, curator. My question, two questions. So first was on the slide, the different engines had different weights, and then you how do you measure, how do you set the weights? Different engines, different weights. So how do you assign weights, and how do you calculate? They're not fixed. They depend on different factors. For example, if the weight of triangulation on ping depends on whether this hop is next to unicast or an exchange. So then this weight is selected and calculated. Do you have white paper that describes how these weights change to make it? I'm not authorized to answer, but I will see how it's done. Yeah, so we'll discuss it later. And the second very short question. Are there any constraints on loads? Yes, loads. Recommit on queries of IPs loads. Any constraint and limitations? No, if this IT is if he's there or not he's there. No, if so you can just like at IP you can ask IP and then you can get geolocation. But there's no credits. No, it doesn't cost any credits. No. So are there any rec family so for use limits? Limits. He's saying limits. I cannot understand what he's saying. No limits, as far as I know, because there aren't many measurements there. So there are no limits. So tomorrow we'll get the amplification report. Right. Okay. Thank you.